Hello everyone, what I'd like to do is talk about sine, cosine, tangent, cosecant, secant, tangent, cotangent. There's signs on the unit circle. And then I also want to just give us some exercise on working with the Pythagorean identities. So something to keep in mind, now I really don't have this memorized. If I need it, I just kind of build it from scratch. But what I'm going to do is I'm going to think about what the sign of the 6 trig functions are in any of these 4 quadrants. Okay, so if we're in the first quadrant, remember that sine is the y-coordinate and x is the cosine is the x-coordinate. So in this quadrant here, x is greater than 0 and y is greater than 0. Here x is negative, y is positive. Over here x is negative and y is negative. Here x is positive and y is negative. But remember, we discovered on the unit circle that the cosine of theta, or the cosine of t, whichever you want to use here, cosine of theta is the same thing as the x-coordinate, and the sine of theta is the same thing as the y-coordinate. So that means in the first quadrant that cosine is positive and sine is positive. Similarly, in the second quadrant, cosine is negative and sine is positive. In the third quadrant, cosine is negative and sine is negative. Over here, fourth quadrant, cosine is positive and sine is negative. Okay. So let's think about the other ones. So for example, let's think about tangent, for example. So there's 2 ways you could think about this. One, you can remember that tangent of theta is the same thing as sine of theta over cosine of theta. But that is the same thing as slope. So if you'd like to think about it, you could think that sine is positive and cosine is positive. So a positive divided by a positive is positive. So tangent of theta is positive. But another way to think about it is, remember, tangent is the same thing as the slope of the line that's moving in here. The slope of the line is always positive in the first quadrant. That might make you think if we're in the second quadrant, tangent, the slope of this line is negative, so the tangent must be negative in this quadrant. We could also think tangent is sine over cosine. A positive divided by a negative will be a negative. So tangent of theta is negative here. Similarly, over here, we'll have that the tan of theta, well, it's mean 2 negatives, sine divided by cosine, a negative divided by a negative is a positive, but also the slope of the line over here, that's a positive slope. I'd be going uphill, so tangent is positive here. Similarly over here, if we think about that line as it's rotating around, as I get over here, this line, the slope of this line is negative. Or you could think a negative divided by a positive is a negative. So tangent of theta is negative in this quadrant. Now remember, the other trig functions are just the reciprocals of these. So if cosine is positive, its reciprocal will also be positive. So here we have that secant of theta would be positive because secant is the same as 1 over cosine. We'd also have that cosecant of theta would be positive. Cosecant is the reciprocal of sine, and cotangent of theta would also be positive because cotangent is the reciprocal of tangent. And similarly over here, we'd have that secant of theta would be negative. We'd have that cosecant of theta would be positive, and we would have that cotangent of theta is going to be negative. Again, over here, we'll have that secant of theta will be negative. Cosecant of theta will be also negative. And that cotangent of theta will also be negative. Over here, we'll have that secant of theta would be positive. Cosecant of theta will be negative, and cotangent of theta will also be negative. Okay, again, I don't just have this whole table here memorized. I think about it whenever I'm working with the unit circle. I just think about that sine and cosine are the x and y coordinates in the unit circle, and I think about whether I'm positive or negative. Tangent is the slope of the line. Tangent is the slope of this line when I'm rotating around the unit circle. I think about whether that's positive or negative. And then for these other ones, I just think about whether sine, cosine, and tangent are positive or negative, and the reciprocals will have the same sign. Okay, so let's do some examples with working with the Pythagorean identities. So a lot of these exercises you could do equivalently just by working with a triangle, but hopefully there'll just be some good exercises of just working with the Pythagorean identities. You often don't use them in this way, but again, these are just great exercises. Okay, so let's say, given that cosine of t is equal to negative 12/13, and t lives in, let's say, quadrant 3, we're going to go ahead and find the other 5 trig functions. Of t. Okay. So what we're going to do here is, I guess right off the bat, what's the easiest one to find here? Well, the easiest one to find here, if I know cosine, I can easily find what secant is just by doing the reciprocal. So right off the bat, this is almost a give me. I know that secant of t is going to be negative 13/12. Awesome, that's a freebie. Okay, let's try to find sine. Remember, cosine and sine are great buddies, and there's a nice Pythagorean identity that relates sine and cosine together. Remember, we have that sine squared of t plus cosine squared of t is equal to 1. Okay, so if I know cosine, I can solve for sine. So here, I'll have that sine squared of t plus, well, cosine is negative 12/13. Squared will be equal to 1. So what are we going to get? We'll get that sine squared of t is, let's see, plus, what is it? Negative 12 squared, well, it'll be 144. 13 squared is 169. Will be equal to 1. Let's subtract 144 over 169 from both sides. So we'll have that sine squared of t is going to be equal to, think about writing 1 as 169 over 169. So I'll have 169 over 169 minus 144 over 169. So let's see, what's a 169 minus 144? Let's see here, so what, 6? I don't know, adding is hard. So I'm just gonna use my calculator. It's one of these funny things about being a math major is when people ask me what my job is, I say I teach math for a living, or I'm a math teacher, and they're like, oh my gosh, what is 512 times 613? And I'm like, I don't know, you got a calculator? I don't know, adding is hard. So I don't know, what's 169 minus 144? 25. So we have that sine squared of t is going to be equal to 25 over 169. Let's square root both sides. So sine of t is going to be equal to the plus or minus the square root of 25 over 169. So the square root of 25 is 5. The square root of 169 is 13. So this could be plus or minus 5/13. So is it going to be the plus or the minus? Well, let's think about it. Well, t is in quadrant 3. So if I draw our unit circle, okay, we're over here in quadrant 3. Well, in this case, the y-coordinate is negative, so sine is negative. So I'm going to choose the negative value. So what we have now is we have that sine of t has to be equal to negative 5/13. So be negative 5/13. Let's go and erase that. Okay, so now that I know what sine of t is, I can quickly figure out what cosecant is. Remember, cosecant is reciprocal, so cosecant of t is the reciprocal of this, so this will be negative 13/5. Okay, so let's find the other ones. Well, let's find tangent. I mean, we could use a Pythagorean identity here if we'd like, but remember tangent is the same thing as sine of t over cosine of t. So tangent of t, well, I already know what sine of t is. Let's see, sine of t is negative 5/13. And cosine of t was given to us negative 12/13. So this is going to be a negative 5/13 times a negative 13/12. Notice that the 13ths cancel. Come on, why do I keep using this marker? The 13ths cancel. Two negatives, I'm going to get 5/12. So now I know that tangent of t is 5/12, which must mean that cotangent of t, which is the reciprocal, which will be 12/5. And this is the answer. Hope you enjoyed that. We'll see you in the next lecture. Thanks.